Welcome everyone. This is going to be our Algebra 2 sequences series lesson on how to find the nth term for an arithmetic and geometric sequence. Probably part 1 in this case because in this situation we are going to be given the sequence itself and asked to find the nth term. We see here that and also asked to find the explicit formula, which is going to be part of the process of finding these things. All right, and before we begin, thanks so much for watching and appreciate your views. Please also, if you can, give this video a like if you find it helpful and subscribe to the channel if you have not done so already. Okay, so our first question here is find the common difference, the term named in the problem, and the explicit formula. Okay, well, the common difference we have done in a couple of videos already, so we know that we're just going to take the second term minus the first term, and 11 minus 17 would be negative 6. We see the third term minus the second term. We also get negative 6. And the fourth term minus the third term will also give us negative 6. And we should begin the same thing over and over again. So D is equal to negative 6. Now, here's the thing. To want to be able to find the term named in the problem, in this case the 39th term, and its explicit formula, we'll do kind of the same. Basically, it's all part of the same problem. So let's discuss this. When trying to find the nth term of an arithmetic sequence, we'll use our formula a sub n equals a1 plus n minus 1 times d. That's the formula to find the nth term of an arithmetic sequence. We will first identify the first term, and in this case, it's sometimes given to us, like in these problems, but we may have to find it in other ones. So we may come to a part 2 video where they get a little more complex. We will then find the common difference d. We can usually determine that by taking the difference of any two consecutive terms in the arithmetic sequence, which is what we did. So common difference is important to find, which we did. We want to find the first term. And once we have the value of a1, n, and d, we plug them into our formula to find the nth term and calculate. Now, we use the number of the term for n. In the problem, they find us in the first problem here, we have to find the 39th term. That means n is 39. Now, if we're asked to find the explicit definition, we will leave n alone and just plug in the first term and d, and then simplify. So we see it's all part of the same process. We might find the explicit definition first before we find the nth term. So our formula, a sub n equals a1 plus parenthesis n minus 1 times d. And so here our first term is going to be 17. So here's 17. N minus 1 times, and our common difference is negative 6. So the nth term will be 17. We distribute the negative 6 to get negative 6n plus 6. So a sub n is equal to negative 6n plus 23. And that will be the explicit definition. So we find the explicit formula first. You say, well, why do that for? Well, now that we have a sub n as a formula, we're going to plug in 39. How do we know? Well, the 39th term was going to be our n term. So we have a sub 39 is equal to neg 6 times 39 plus 23. And so here, try to figure out in this case, let's see, 39 times 6, 1 times negative 6, but we'll multiply 6 and take a negative there. And we're going to get 4, carry the 5, 18 plus 5 is 23, 234. Okay? And so that's really neg 234 plus 23, which really is going to be a subtraction. So subtract here, we get negative 211. So the 39th term, a39, is equal to negative 211. Okay, So yes, we find our formula explicit the formula first, and then we will then plug in the n value. So that makes things a ton easier for us. Let's now find f. Well, technically it should be a and b. So, but that's okay. It's continuation from the last video. So, all right, here we go. So again, we're going to find our common difference. We see -5 minus 5 is equal to -10. -15 minus 5 is equal to -10 because when you minus -5, sorry, minus -5, right? Because you subtract negative as same as adding a positive, and -25 minus -15 is equal to -10. So our common difference is going to be -10. Well, I forgot to put a box around my common difference for the previous one. So make sure we have that for our question F. And then we want to find our formula again. We'll see in this case here, we're going to use a sub n is equal to, this time a1 is going to be 5 plus n minus 1, our common difference is -10. We'll distribute this, right? So a sub n is equal to 5 minus 10n plus 10. And then, of course, we're going to combine like terms. So our explicit formula will be -10n plus 15. Now, someone might ask, can I write down 15 minus, oh, forgot the n. Don't forget the n there. Someone might ask, can I write down 15 minus 10n? That will still be correct. I just like having everything in descending order. And so now what we're going to do is we're going to plug in 20. So we have a 20 is equal to -10 times 20 plus 15. And that's equal to -200 plus 15. The 20th term in the sequence is equal to -185. Okay? All right. So let's move on. Find the common ratio, the term name in the problem, and explicit formula. And, well, the last problem was F. This should be G. Sorry about that, ladies and gentlemen. So, G. Yeah, EF, G, yes. And then this problem was called H, because they're all part of the kind of a big group of problems. So, all right. And so, common ratio, not a problem. We know we take, in this case, 12 over 4 is equal to 3. And we know that 36 over 12 is equal to 3. And yeah, even 108 divided by 36 is equal to 3. So our R value is 3. Okay, but now to find the formula, the explicit formula, and of course the nth term. When trying to find the nth term of geometric sequence, we use our formula a sub n equals a1 times r raised to the power of n minus 1. We may have to identify the first term. It's sometimes given to us, but we may have to find it though. And again, for our part 2 video, the more complex problems, we'll see how it's done. We will then find the common ratio r. We can usually determine that by taking the ratio of any two consecutive terms in the geometric sequence. This is how you know I've been using old notes. The same thing. So it should be geometric sequence. Sorry about that again. Once we have the values of a1, and an r, we plug them into a formula, find the nth term, and calculate. We use the number of the term for n. We also find this definition for the any nth term by simplifying the formula after plugging in a1 and r. Same as before for the arithmetic, except we have a different formula for geometric. So our formula here is a sub n equals a1 times r to the n minus 1. The simplifying part might be a little more difficult, but we'll get to that in a minute though. So let's plug in our a1 value. We know should be 4. So we have a sub n is equal to 4. Our common ratio is 3, and raise the n minus 1. Now, what does this 3 raised n minus 1 really mean? Well, we'll have 4, and when we are subtracting two, when we divide two numbers same base, we keep the base and subtract the exponents. In this situation, what we're going to do is kind of work backwards, and so rewrite this as 3 to the n divided by 3 to the first power. Therefore, if we were to simplify for the explicit formula, a sub n is equal to, take this 4 over 1 times, and then of course multiply everything out, we have the denominators being 3, so we will have 4/3 times 3 to the n power. That will be our explicit formula, okay? So all we're doing is kind of pulling out one from the base and dividing our a1 term, okay? Now, what we're going to do is we're going to calculate a9, and we'll break out a calculator on the side. So a9 is equal to 4/3 times 3 to the 9th power. Now, you could have also, if you want to, done 4 times 3 raised to the 9 minus 1 power. It's the same thing, okay? And this might be a little easier because really it's 4 times 3 to the 8th power. So now let's calculate 4 times 3 to the 8th power on the calculator. All right, so let's see now. We'll take 3 raised to the 8th power, 3 raised to the 8th power with your calculators. We get 6,561 times 4. And we're going to get, in this case, a9 is equal to 26,244. Okay, and that's going to be our ninth term for this geometric sequence. We'll do this one for h. So 6 divided by -2 is -3. -18 divided by 6 equals -3. And 54 divided by -18 equals -3. So our R value is 3. Just to make sure we box our answers here. We're going to use our formula, okay? And our formula here, a sub n is equal to a1, which is -2, times the R value, which is 3. It worked out to be, oh, -3. Oops, sorry about that. I almost put the wrong number down there. -3. Ooh. To the n minus 1. And so as our general formula, it would be a sub n is equal to -2 over -3, one of the bases, times -3 to the n, which is going to be 2/3 times -3 to the n power. That's our general formula. That's a sub n. Okay? Now to find the 12th term, well, again, you could do a12 equals -2 times -3 to the 12 minus 1 power, which is -3 to 11th power. All right, and so in this case, we'll take -3 raised to the 11th power, and we get -177,147, and then multiply that by -2, right? Times -2, and we get a positive number. This is a really big number here. 354,294, and that's your A12. Okay, ladies and gentlemen, thanks for watching. Please make sure to like, subscribe, and look forward to seeing you in the next video. All right, let me make this full page so you can see everything. Okay, everybody, take care. See you next video.